Hello everyone, I'm Faiza and I'm delighted to do this presentation. Today I talk about neural network and some algorithms. In today's presentation, I quick look at what's on the neural networks web page. Okay, let's start with a definition of neural networks. Basically, neural networks are algorithms and computing systems based on the human brain. As our brain are good at recognize patterns, neural networks do the same. Not only can they recognize patterns in complex data sets, but they can also interpret and label sensory data like we can. Now there is a question, what makes neural networks unique? We can say their ability to learn and make decisions, but how? By labeling and clustering raw inputs, they can make predictions and choice with an ever increasing accuracy by iteratively processing and adapting their algorithms. Plus, they're flexible enough to work across industries. For example, in engineering, they optimize designs and process. In finance, they predict market fluctuations, and also they have some things to do in healthcare, technology, and so on. But there are three things that make neural networks work, and we should know them. To get started to work with neural networks, we should create nodes and connections. We simulate the neurons and synapses in the human brains. Next are weights and biases, the editable parameters that refine the network's learning, ensuring precise outputs from different inputs. And last but not at least, activation functions are the checkpoints deciding which nodes fire to enable nonlinear problem-solving methods. All these things combine to form neural networks. I'm gonna speak about neurons before starting talk about algorithms. So let's dive in. Each neurons, this figure is a simple neurons. Each neuron in a network process input signals that are weighted by these symbols to signify their importance. The neurons then adds these weighted inputs together and includes a bias, a unique value that allows the neuron to better fit the data. This result is passed through an activation function which determines the neuron's output. The neuron uses this function to capture nonlinear complexities in data. Inputs are received, each input is weighted, and a bias is added. The weighted inputs are summed, passed through an activation function, and then the neuron outputs a signal. In this way, neural networks simulate how neurons behave in their brain so they can perform complex tasks. The neural networks website mentioned there are many algorithms for neural networks, but for time's sake, I'm just going to cover few of them. Before we talk about those advanced algorithms, let's talk about feed-forward neural networks. These systems represent the simplest form of neural networks where data flow in one direction only, from input to output. This one-way flow ensures that the information processing is straightforward and linear without any loops and or feedback paths. It's these networks that lay the groundwork for more complex neural architecture, providing a clear and fundamental understanding of how neural networks can simulate decision-making process. And autoencoders. The autoencoders is a kind of neural network that used for unsupervised learning. Autoencoders are designed to process data by encoding it into more compact representation and then reconstructing the outputs as closely as possible to the original input. Autoencoders have two main parts, encoder and decoder. The encoder compressed the input into a lower dimensional representation in the latent space. You can see this figure is a schematic illustration of what encoder do. The decoder then takes this encode data, and attempts to reconstruct the original input from this compressed knowledge. The process is useful for stuff like dimensionality reduction, feature learning, and even denoising data. Autoencoders tell us what's hidden in unlabeled and unclassified data. This makes them powerful AI tools. Another neural networks algorithms, advanced neural network algorithm, is a recurrent neural networks, RNNs. They are one of the most advanced neural network algorithms out there. With RNN, you can recognize patterns in sequence of data, which is why they're perfect for tasks like time series analysis or natural language processing and speech recognition. What sets RNNs apart is their ability to maintain a form of memory. They do this by having neurons that get information not only from the input layer but also from their own output. As a result of this recurrent connection, The network can carry information through the processing sequence. This GIF shows how data flows through the RNNs. In this slide, I'm gonna talk about long short-term memory networks, or LSTM. They are a special kind of recurrent neural network that remembers information for a long time. RNNs struggle to maintain long-term dependencies due to the vanishing gradients problem, but LSTMs don't have that problem. LSTM are unique because they have a memory cells and 3 gates: inputs, outputs, and forget gates. This allows the network to selectively remember and forget patterns by controlling information flow into and out of memory cells. This makes LSTMs incredibly effective for complex tasks that require understanding over time, such as time series prediction. As you can see in this figure, LSTM is it has the complex structure. This figure shows an LSTM block diagram showing how information flow through the gates and affect the cell states. Also, these legends help us to understand better about the elements that there are in LSTM block. The LSTM excels at analyzing and predicting sequence, making them perfect for flood assessment. What's my research area? The LSTM can learn the complex temporal relationships that lead to flooding by processing historical weather patterns, by remembering and weighting long-term input sequence. They can predict floods better than traditional model. As well, LSTM can be trained to consider the sequential nature of rainfall, melting snowpacks, and subsequent water flow rates, providing an advanced warning system in order to mitigate the impact of natural disasters. Engineers and city planners can predict how quickly water level will rise in a river basin and defense with floods. And all of things I gained from this algorithm was this. Thank you so much for your time, and I appreciate your attention.